Just doing a quick sound test, guys. Looks like we're good to go. All right, just got to do final kind of things, and then we should be all right. Where is it? Chat is all good. Okay, guys. So welcome to the level 2 calculus tutorial, guys. So what we're going to be doing today is pretty much covering. This is from 2017 paper. These questions, but they're all parallel questions. So because they're parallel questions, all I've done is I've just kind of changed the numbers up a bit, and let's just give the questions a go. So basically, there are 5 questions that we're going to be covering today, and they are worth. We got achieved a couple of merit questions, and the last 2 questions are excellence questions. All right. So I will leave this up here. So if you guys want to take a screenshot and kind of work on it and then come back later, that's fine as well. Otherwise, just bear with me and we'll actually go through each one of these questions one at a time. Yeah. All right. So just how to, sorry, just give me a second. I'm just trying to sort out a couple of things with my stream. With the chat. Yep, sweet as. So, guys, if that's good, we're going to get started with these questions. So I'm going to start off with question 1 right here. So as always, I'm going to give you guys maybe a couple of minutes to try and do these questions by yourselves, and then I will start going through the answers. Yeah, the Marvelous have been kind of messing around with some of my new computer settings. Cool. So as always, anytime you start off with a question, you're going to get a nice achieved question to start off with. So with this particular one, all you've got to do is you've got to differentiate it first. And once you differentiate it, substitute the x value and get what the gradient is. So we've got to go f dash of x. So if you go f dash of x, what you're going to end up with is 4x cubed plus 4x minus 4, and we kind of leave it like that. All right, so that's what our gradient function is. So our next point is to try and solve for when x equals to 2. So we're going to put f dash of 2 equals 4 times 2 cubed plus 4 times 2 minus 4. Working this out, you should end up with 36 as your answer, which actually should give you an achieved grade. Now, in saying that, look, sometimes it's a really good idea to actually know how to use the calculator as well to check the answer. I'm just going to quickly run this through, and I haven't done this in a while, so just bear with me. I believe you can just do something like this. But let's actually see if it actually works out. So this is another good way to check whether your answer is correct or incorrect. But let me just see if this works, because sometimes I forget these calculator instructions, and it doesn't go very well when I plan it. Okay, so it does work. So what you can do is you can actually use your calculator to check your answer as well. So just it makes it a lot more easier in the sense that you actually know that you've got the right answer and you can feel confident about it. So in fact, I would actually say you could use the calculator and skip the second line completely and just punch in the answer straight away. So to do that, in your calculator, just click on menu, go into run mode, and click on option, which is this button here. And then there's a little button called calc. So click on calculus. And there's a thing here called d of dx. All right, so you can just click on that, make sure you type your whole equation, which is the top equation, which is x, so not the differentiated one, just the original function. And so we're going to put 2x squared minus 4x plus 2, and put a little comma, and you've got to put x equals to 2. So we're going to put that 2 there. So this 2 is saying that when x equals to 2, I want you to tell me what the gradient is. And you press equals, you get 36. So yeah, nice, easy question to kind of start off with. Can we go on to the next question, guys? Or do you want another practice one like this? All right, so next question is coming up to be a merit question. I might just readjust this, if I can figure out how. All right, guys, so this is a two-part question here. So what you've got is you've got to actually find the equation of the tangent to the function. So what I'm going to do is I will kind of show you guys, well, how to do it in the calculator, some parts of it, and some parts of it you should be able to kind of work through it. So I'll give you guys maybe a couple of minutes just to have a go at this question. And again, remember that if you forget what to do in the paper, and you've got something like f of x, like in this case, you've actually given f of x right there. If you differentiate it, it's always a good starting point. All right, so differentiate and find the gradient is always a good starting point. If you don't know what to do, differentiate, find the gradient, something. It always tends to work out. So what I'm going to do is, for this one, I will kind of give you guys a bit of a rough idea what's happening. But what you could also do is just sketch the graph real quickly on your calculator, just so that you can actually have a look at what this graph looks like. All right, so we're going to put this graph here. We've got 4 plus 10x minus 3x to the power of 3. And we're going to draw this graph. So right now you can see this graph. It's kind of like this wonky as cubic. So I'm going to zoom out a bit. I don't think it's going to help me much. Yeah, you can kind of see this looking shape right here. Where is it? Something like this. And we want to know when x equals to 1. So when x equals to 1 is somewhere there. So we're probably going to end up with, I'm trying to draw this, but this is going to be a terrible graph, but you get the idea, when x equals 1. So something like this. But anyway, what we're going to do is we are going to differentiate f of x first. So when we differentiate f of x, we're going to get f dash of x. So f dash of x is equal to 10 minus 9x squared. Sorry, forgot that. I knew something looked very weird. 10 minus 9x squared. Now, this is the gradient function, right? So we got to find out what the gradient is. So when x equals to 1, so I'm going to put down f dash of 1, which is going to give me 10 minus 9 times 1 squared, which is equal to 1. So f dash of 1 is equal to 1, which basically means that the gradient when x equals to 1 happens to be 1. So if you want to find the tangent, to find the tangent, we're going to need a gradient, and we're going to need x and y point. All right, so if you want to work out a tangent, so for a tangent, we need x and y coordinate, and we're going to need gradient. Now the gradient we've already got, because the gradient is equal to 1, so we can say that m is equal to 1. We also know what the x value is, because the x value is equal to 1. We actually need to go we need to actually figure out what the y value is. all right, to solve this question. So that means we got to go back and we got to figure out what f of 1 is, because f of 1 actually gives y value. So when we do that, we're going to get 4 plus 10 times 1 minus 3 times 1 cubed. So this ends up being 4 plus 10 minus 3 gives us a value of 11. So the points that you're going to have to deal with is we've got 1, 11, and the gradient also happens to be 1. So at this point, we're going to put this into equation of a straight line. So equation of the straight line, if you've forgotten, it is given to you guys in the formula sheet, which is this right here. You could also use y equals mx plus c, and that you still end up with the same answer anyway. So it's no big deal. So you can use either one of them. All right, so I'm going to work with this one. So which means I've got x1, I've got y1, and m. I'm going to substitute all these values, and I'm going to end up with y minus 11 equals 1 times x minus 1. So I'm going to get y minus 11 equals x minus 1. Rearranging this, I'm going to get y equals x minus 1 plus 11, which then could be said as y is equal to x plus 10. So basically at this point what we've got here is just in terms of grades. Grades wise, the question is going to be, we've got achieved is deriving and actually finding the gradient, and then merit is going to be getting the final equation. So any questions, chuck it up, guys. I usually don't kind of pay much attention to the chat when I'm explaining. Yeah, feel free to put answers up there. That's not a problem. So guys, as I said to you, if folks want to kind of go ahead, that's absolutely fine. There is, as I said, I'll put the questions up. You can have a look at earlier. I put the questions up so you can go to the start of the stream, or even go to my OneNote and you'll see the tutorial questions up for today. All right, so would you guys like another question like question 2, or can we move on to question 3? Oh, did I miss something? Yep, so I think we're kind of done with this question anyway, because that was good to go. All right, so let's have a look at this question here. So this one, kinematics, just remember that when you start off with kinematics, you got distance or displacement. Differentiated, you get velocity. Differentiated again to get acceleration. Yep, so guys, just another one. If you forgot to take the screenshot of all the questions, it will be in my OneNote link, which you can kind of see in the description. So have a look there, and it's on level 2 calculus, I believe. Yeah, under level 2 calculus, you'll find under tutorials, the questions should be there. Okay, so as always, I'm going to give you guys some time to kind of work through this question. And then we can actually go back. Sorry, we'll go through the question. I'll give you guys a couple of minutes. Yeah, nice. I think people are getting 7.6. That's always positive when you have like a lot of people getting that answer. So this question here, what do we got? We've got velocity that's actually been given to us, and we want to find out when is the acceleration 2.8. So remember that when you have velocity function, if you differentiate velocity function, you're going to end up with the acceleration function. So in this case, a of t is differentiation of the velocity function, which is going to give you 0.5t minus 1. And since this is the acceleration equation, just this part right here, just doing this will get you an achieved grade, all right? So you are just differentiating from velocity to acceleration, but guess what? That still gives you an achieved grade. So to solve the question, so in this question, it's actually saying when is the acceleration, so what is t when a is equal to 2.8? So we're going to put 2.8 is equal to 0.5t minus 1. Rearrange it. We're going to get 0.5t, 2.8 plus 1. And so we're going to get 3.8 equals 0.5t, and t is equal to 3.8 divided by 0.5, which actually gives us t is equal to 7.6 seconds. Grade for this question ends up being a merit. Mark, both of the formulas that you actually use for kinematics in physics is pretty much the exact same thing as calculus. In fact, I think all the formulas that you use for physics kinematics can be differentiated and integrated to get each of the other equations. Yeah, you'd be surprised, Zaddy. This was a merit question from 2017 that I've just rewrote. That's all. Yeah, Beckham, I'd actually say just be careful with that, because I know that the markers have actually penalized guys for using physics kinematics equations in level 2 calculus. So just be mindful of that. Confusion, yes, the next two questions that we're going to be doing is both of the next two questions are going to be excellence questions, all right? Akil, at the moment, I'm supposed to do my schedule, which I haven't finished yet, but I think I checked there's about 6 or 7 tutorials for all 3 levels that we're going to be doing. But I'm going to kind of be doing this format here, so I'm just going to do like one question from past exam paper, but I'll actually rewrite the questions so that we can kind of go through all of them. All right, guys. Anyway, look, let's move on from this question. Let's go to this one here. Now, this question is an excellence question. I'm going to put it out there for you straight away. And it's all right, Horsey. It's not a problem. Yeah, so I'm going to leave this question out there for you guys just to have a read through and kind of go through this type of excellence question, which I've seen pop up here and there. Ethan, you could have actually left it as 7.6 as well. I'm just checking the answers. There's nothing that says about units. So you could actually left it as 7.8 as well. The Marvelous, I believe someone else. Oh no, wait, that was just you putting A equals to 22. Ethan, was that in your school exam or the actual exam? Yeah, that's a bit sad, to be honest. To lose a complete mark for S, that's just silly, man. I'm sorry. All right, guys. So how do we go about doing this question here? Now, let me just have a look. X coordinate calculator for the original function. Okay. Yeah, so Ali and Damian, it doesn't matter which formula you use for the equation of a straight line. Either one is going to work. They both will work, so it's not a problem. So what I'm going to do is I want to show you guys kind of how to approach these types of excellence questions, right? Because most of the time, it's just trying to visually see it. If you visually see what's happening with this question, then you can kind of start going which step by step you can actually start working out. Zadie, I think quite a few of you guys got that 22. So for those of you guys that haven't started yet, just to kind of give you a bit of an idea. So if you look at this particular graph, have I got it right? Yes, I have. So this is a quadratic right now. When you look at this graph here is a quadratic. Now, at some point, it's going to have a gradient of 8. And the tangent of the tangent, so the tangent is, let's just go with the green line here. So the tangent has a gradient of 8. So at this point, some point, wherever it is, its slope is actually 8. Eventually, it's going to pass the point 5 and a. So now that 5 and a could be here, or it could be here. We actually don't know what it is. But what we do know is if we find the equation of the green line, then we can actually substitute 5 to figure out what the value of a is. All right, so we've actually got to find the equation of the green line. To find the equation of the green line, remember that equation of a tangent. So I'm going to write this here. So if I want to find the equation of that green line, I'm going to need x, I'm going to need y, and I'm also going to need the gradient. Right now, the only thing that I have is the gradient. All right, because the gradient is equal to 8. So that's the only thing that I have right now. I need to figure out what the x and y value is. So to do that, what I could do is, because I have f of x, which is 2x squared minus 4x, I can work out what f dash of x is. So when I work out f dash of x, I'm going to end up with 4x minus 4. So now this is the gradient function. So, and I know the gradient function is going to be 8 at that point. So I'm going to put it as 8 is equal to 4x minus 4. And if I rearrange it, I'm going to get 4x is equal to 8 plus 4, which means I've got 12 is equal to 4x and x is equal to 3. So now I've figured out what that point is, which is going to be 3. So that means 5 and a is going to be there somewhere. Now I got to figure out what the y value is. So to figure out what the y value is, I can actually do f of 3. So if I go f of 3, that's going to give me 2 times 3 squared minus 4 times 3, which is 18, take away 12, which ends up being 6. I hope I'm doing this right because I'm kind of rushing it through at the moment. Did anybody else get 3, 6? Somewhere there? I didn't see it. It's all right. Let's just keep going. Yep, so 3, 6 is the coordinate. So now that we've got the coordinate, we've got the gradient, so we can actually write the equation of a straight line. Now I know that we talked about earlier whether we can use y equals mx plus c or we can use the equation of the line. I'm going to use y equals mx plus c. All right, so when I do this, my point is 3, 6, and the gradient is 8. And so what I'm going to end up with is 6 is equal to 8 multiplied by 3 plus c. 6 equals 24 plus c. Therefore, c is equal to minus 18. So the equation of the green tangent or the green line is 8x minus 18. So if that's the case, now I should be able to substitute 5 and a to figure out what the, sorry, I can substitute what 5 is and to figure out what the value of a is. So I just substitute 5 and I'm going to get 8 multiplied by 5 equals 18, sorry, minus 18, which means I got 40 take away 18, y is equal to 22, or in this case, I can say, therefore, a is equal to 22. So that is pretty much how we end up doing question 4 there. I'm going to ask you guys, would you guys like another question like that, or you happy with it? All right, so let's actually, what I'll do is, I think I want to spend a couple of questions like this. So what I'll do is we'll actually do question 5 first. While we're doing question 5, which is another excellence question, we'll come back and do 4b, where I try and create a question. All right. So, oh, grades for this question. Good point. Good point. Good point. Good point. So, for grades for this question, you will get achieved up to here if you actually figure out what the gradient, where the x value is. Then, correct y coordinate found for the original function. The correct y coordinate, this part here, gets you a merit, getting up to here. Expressions for gradient found and value. And finally, this part here gets you an excellence, getting that a value. So yeah, it's like that excellence part, you've got to do just a little bit more work there. Okay guys, so I'm going to put up question 5 and I'm going to get you guys to have a go with question 5. While you're doing question 5, I will try and create question 4b. All right, so let me just put this question up here. There we go. That's all the information I'm going to be giving you for question 5, which also ends up being an excellence question. Yep, we've got a couple of answers coming through, so have a go. And I got to come up with 4b. Where to go? I'm actually going to make 4b a little bit more, a little bit challenging. I don't know if it'll work, but let's try it out. Got nothing to lose. It's weird trying to come up with questions on the spot. Like, you have to kind of mess around with the equations a bit to try and make it work. Sometimes it works, sometimes it doesn't. Yeah, Vandan, check my Sorry, I've got to update the schedule. Once I update the schedule, man, there should be some level 3 tutorials coming up soon. All right, so there's a gradient of oh yeah, that's not a bad question. Okay, guys, I got 4b. So let's actually go through question 5 first, and then after that, I'm going to go through, give you guys 4b after that. So what do we got? So with this question, what we've got here is we got this function that's been given to us, and we've been told that the turning points are when x equals -2 and x equals to 0. So our first step is really, in this case, to differentiate this function. All right. So when we differentiate this function, we're going to get 3x squared plus 2ax plus b. And to be honest, you're probably wondering, it's like, well, what do we do from this point onwards? Well, remember that when something says it's a turning point, that means the gradient at a turning point is equal to 0. So in this case, because -2 is a turning point, we can say that f of -2 is equal to 0. Then we can also say that f dash of 0 is also equal to 0. So there is a turning point when x equals to 0. Because of this, we can actually set up two equations. Our first equation is going to be 3 times -2 squared plus 2 times a times -2 plus b. And our second equation is 3 times 0 squared plus 2a times 0 plus b. I think I gave you guys some really easy numbers to work with in this question. I just realized it shouldn't have been 0, but that's all right. So basically, if you look at this, if you were to, ideally what you should have got is, you should have actually got a simultaneous equations, but because I made up this question about like 20 minutes before the start of the tutorial, I didn't check it properly. In an exam situation, you wouldn't have got 0 here. What I mean by is this part right here. You wouldn't have got a 0 there because that makes the equation really easy. But that's all right. I mean, as long as you guys understand that you've got to set up simultaneous equations, and because it's a set of simultaneous equations, it actually ends up being an excellence question. X, -1 and -3. Yeah. So it ends up being an excellence question because it's a simultaneous equations that you're doing to solve this this question. But in this case, we're lucky. We can straight away say that b equals to 0. And then going into that first equation, we've got 3 times -2 squared, which is 4 and 3, 12, minus 4a plus 0. Rearranging it, we're going to get 4a equals to 12, and a is equal to +3. All right. So, yeah, I mean, this question, I would say, because you guys didn't have to do massive simultaneous equations, it's probably a merit. But in the exam, it will end up looking like a excellence question if you were to do full setup simultaneous equation. All right, so I've got question 4b for you guys. Kind of need to write it up, so just bear with me. Okay, so the equation, let me just put this up here. Where is the question? Tangent to graph of a function y equals to x cubed minus 6x squared plus 8x plus 2 has a gradient Let me just check if it actually works. Passes through. Oh, this is a good one. Would that work if I put it as? Would that work? Let me just check. Sorry, give me 1 second. Just want to check if it actually is going to work out. Oh, yeah. Let's do it this way. All right, guys. So I've got this next question for you. Tangent to the graph of a function, this function has a gradient of -3 and passes through B15. And I'm going to ask you guys to find B. How did I get 12? It was 3 times -2 squared. Ali, so it was 3 times -2 squared. -2 squared is +4. +4 times 3 is 12. Yeah, sorry, I kind of moved on from that question, but it's all right. Feel free to ask questions, guys. Nah, Lucky, I don't do probability, unfortunately. Sorry. Rage, there's heaps of level 2 algebra tutorials that I've done before, so feel free to check them out, man. Nah, I think level 2 is not too bad compared to level 1 MCAT. Level 1 MCAT is just annoying. It depends, Rashab. What do you want to do? Like, if you're thinking of doing engineering, you'd probably need to be doing calculus. You're getting 2 values for it. Ah, damn. Did I give annoying numbers to you guys? Oh, yeah, it actually will have 2 values to it. Okay. All right, fair enough, guys. Let's change that question up a bit. That's all right. Sorry, I'm going to change that question up because I just had a look at that graph again, and it is an ugly graph. Yeah, you are going to end up with two different values. So let's change that up. Sorry about that. See, this is what happens when I try and come up with questions on the spot, because it's always ends up that I just make it difficult for somebody. Let's try this one here. Let's get rid of the cubic and actually just leave it as a quadratic. So we'll actually go with 6x squared plus 8x plus 2. Let's try that. Daniel, no. They wouldn't do that, because it's like what ends up happening is you'll end up with like two equations, and which means you could potentially end up with two different b values. So it's like that is too much. I don't think they would ask you something like that. Tough question there, Emil, because I know for a fact that with med you got to have like a high rank score, and kind of banking all of your high rank score on calculus, which it's a bit of a big ask. Like I know with stats you could actually do like majority of it is in internals. So with stats you could actually do internals and kind of get those high grades. But then with calculus you're banking pretty much on externals. Yeah, Tap, it is going to be annoying numbers. That's all right. Sometimes you're not going to get pretty numbers. Rishabh, I don't know what a DGA is, unless I'm misunderstanding. Nope, Harrison, you could actually pass all of your NCEA levels without sitting a single external. Oh, derived grade. It depends, Mano. Like, it's a hard one to say, because, people would say generally stats is better, but, it's a tough one, because I don't know what the universities are requiring right now. So my best suggestion is talk to your careers advisor at school. Most likely physics, definitely do calculus, bulk read. Harrison, depends on which school you go to, man. Some schools, they don't really mind. Some schools, they're a bit tricky. Look, in my kind of opinion, like any kind of maths at a higher level is always going to teach you how to think. So calculus actually teaches you how to think, apply rules, think differently, and of course, go through like high pressure situations, like when you sit them exams. So, it is challenging, but it's a good challenge. All right, look, anyway, let's go through this question. Question number 4B. Has anybody got an answer yet? Because I've not seen a single answer yet. All right, thank you, Archie. We got -7/24. We got a couple of different answers here. That's fine. Let's actually go through this question, all right? So what we're going to do is we got a couple of 7/24s. -7/24s. All right, let's actually go through this question. So what we've got here is we've got f of x. F of x is equal to 6x squared plus 8x plus 2. We're going to differentiate it, which means we're going to get 12x plus 8. Now it says that the gradient is going to be -3, so we're going to put this as -3 equals 12x plus 8, and we're going to end up with 12x is equal to -11, and so x ends up being -11/12. Now yes, I did give you guys horrible questions, which is kind of sad, but hey, guess what? Sometimes you do get horrible numbers. So we've got the x value. We now need the y value, so we're going to substitute -11/12 in the equation. which means we are going to get 6 times negative 11 over 12 squared plus 8 times negative 11 over 12 plus 2. So at this point, I would actually say get into the habit of using your calculator like this. So what you could do is, I usually use the answer function quite a lot. So I actually go negative 11 divided by 12 like this. And what I do is I keep this as the answer, right? So the next thing I can do is 6 times answer squared, which is 6x squared, plus 8 times answer, which is same thing as 8x, plus 2. And what that gives me is this particular value here. Now, if you want, you should be able to click on this F to D button, which changes it back to a fraction. So by doing this, I can see that the y value is going to be negative 7 over 24. So I've got my x value and my y value, and I've also got the gradient. So the x value is negative 11 over 12, the y value is negative 7 over 24, and the gradient is equal to negative 3. So using this, now I can come up with the equation of the line. Sorry, how do you put answer on calculator? IMS. What you can do is, if you look at shift minus button right there, that is an answer button. So you should be able to use the same, how do I say it? It's like, so you don't have to round up the answers as well, like, so you can just kind of use that answer again and again and again. Anyway, let me just go through this. So we've got to find the equation of the gradient first. So I'm going to use this. So we've got negative 7 over 24 equals minus 3 multiplied by negative 11 over 12 plus c. And c is equal to negative 7 over 24 plus 3 times negative 11 over 12. Again, I'm going to do this in the calculator. So I've got negative 7 over 24 plus 3 times negative 11 over 12, which gives me a c value of negative 73 over 24. Ugly numbers, apologies about that. So we've got y equals, gradient was negative, so negative 3x minus 73 over 24. Yeah, sorry, Peter, I kind of just came up with that stupid question in the middle of the tutorial. That's always going to happen. So now the point that we're looking for is b and 15. So we're going to substitute 15 is equal to negative 3 times b minus 73 over 24. So negative 3b equals 15 plus 73 over 24, whatever that is. I guess this is why it's nice having that calculator. So you got 433 over 24 equals negative 3b. So b is equal to 433 divided by negative 72. God, that is a super ugly number. So you should be getting something like negative 6.01 as your answer. Yeah, I agree with you, to Marvelous. That is an understatement, that these numbers are super ugly. Yeah, I think Horsey, as long as you got all the working there, and I wouldn't put it as positive 6.03. If it was negative 6.03, I'd probably say a rounding error and give you that mark. Emily, 2 decimal places, but I found that in calculus, generally, the numbers tend to be very nice in calculus. Yeah, 2 decimal places is always good enough for me. No. Just because you have more decimal places doesn't mean they're going to mark you down. The main thing is that they want to see your working. rather than like randomly you're just putting numbers up. They're going to be like, well, how did he end up getting this number and so on. So as long as you show you're working, even sometimes if you get the wrong answer, like you could end up getting like not carry on errors. Like I know like sometimes in calculus they've done this where one question is actually worth like two, like a T7 and a T8. So you might get like a T7 for a minor error sometimes. So just keep that in mind as well. Now, Rene, what you could do is just kind of like show all your working. Like in this case, I try to keep, especially when you're working with decimals, it's really important to keep fractions because when you work with fractions, you pretty much get accurate answers all the way through. But if you work with decimals, you will end up rounding up early and you'll start getting things a bit messy. So keeping things in fractions is always a good idea. That way you could always end up with the most accurate answer possible. There's Acturian as well, so which is pretty decent money, man. All right, guys. Look, I think that is basically it for today because like we got a nice bit of questions coverage there. So we're basically going to call it for the night. That's all the questions. A volume question. Harrison, I teach at Ormiston Junior College, man. I don't teach level 1, 2, 3 cast anymore. I walked away from NCEA level maths and just doing junior college. Loving it at the moment. Akil, grades wise for the last question. Final answer gets you an excellence as always. So the breakdown of this question is achieved up to here. Getting the Y value is going to get a merit, and excellence is the last part of it. One other thing, just before you guys go away, I just let me just grab my schedule just to see when I've got you guys down for the next tutorial. I have to update that document, but looks like currently I have you guys scheduled in for next week, Tuesday. What are we on? Yeah, Tuesday. Next week, Tuesday, I've scheduled you in for level 2. All right. So we will do, probably we'll do calculus, algebra. I'll put a Instagram vote just to see which one comes up. And then we can actually do that. So I will see you guys again next week, Tuesday on 10th of November. But hang on. Let's just go answer our final few questions. Yeah, next tutorial is on Tuesday. Welcome, not a problem. Horsey, our schools are right next to each other, so it's pretty cool. Yep. Shot at Clyde. Danielle, I can actually answer that question to you because I suck for my kids. Because when you're actually teaching in YouTube, you don't have the pressure of like marking. You don't have the pressure of I don't have to worry about your parents calling me and complaining about your grades. I can teach what I want when I want without having to worry about that extra stuff. Oh, damn, this mouse is like too fast. Hang on, where did we go? Calculus, algebra in terms of difficulty. Horsey, they're both, I know level 2 people say that calculus is easier than algebra. It is, to a degree. I found that calculus has been a lot more straightforward. Algebra tends to be a couple of tricky questions. They always like to make tricky things in there. But overall, they're pretty much, I'd say, just same level of difficulty. Um, so Demarvelous, we'll actually go through optimization next time, all right? So it's not a problem. Algebra, it would be nice. Yeah, so I'll put out a 2 terms to mark 1 page. Which school are you at, Horsey? Peachy Jim, you should hear some of the stories I tell with my kids, because I tell them, I teach maths on YouTube, and they kind of laugh. They're like, nah, they don't believe me half the time. Nice, vexed. Which school are you at, Nikhil? I'm just curious, that's all. Are you marking NCEA maths papers this year? Nah, I never mark any papers. I actually want to enjoy my holidays. O2 or Mote College as well. Damn. One day I'm gonna get a New Zealand map and just kind of like track where these students, where you guys are all coming from. No worries, Shulker. You can actually catch up this on replay once I stop the live stream, man. Oh, St. Ken's. Oh, nice, nice, nice. Nice things, girl. Mark. Yep. It does ring a bell that she was my mentor in Howie College. Still keep in touch with her every now and then if I can. Yeah, she was my mentor back in 2006, I believe. Oh, that's pretty funny. Tauranga, wow. Ruapehu, Christchurch. Oh, who are you, Demarvelous? Come and see me in the morning. Confusion, I've been doing this since 28, God knows, I lost track now. I think 2013. All right, guys. Anyway, look, I will leave that with you guys. Our next tutorial is running. When are we running? When are we running? Tuesday, 10th of November. I will catch you guys then. Have a good one till then. Oh, by the way, if you do have any questions, screenshot the question, send it to me. Socials, all my contact is up there in the side there. And yeah, I've got some time in the mornings. I usually have some time in the mornings to kind of do some quick questions. So if you do have any questions and you need them answered, send it to my email and or Instagram or whatever it is that I have, Twitter. Yeah, I'll happily work out the answer and send a video to you guys. Okay, sweet. That's it from me. Thank you guys. Have a good night, and I shall see you guys next week. Before you go, who you're supporting? Ah, man, jeez, that's a tough question. Yeah, send questions, all right? Catch you guys later. Bye.